All right, hopefully you didn't do what I did in the last one, which is crash Chrome twice, making your while and your for loops. So now we're going to talk about matrix transformations. And this is a way that we can take a shape and draw it in different parts of the screen, rotate it, all without having to do a bunch of crazy math. So let's say that we wanted to draw a shape. If this is our sketch here, and we know that this point here is 0, 0. That's our origin right over here. And let's say we want to draw a shape somewhere on the screen. Now, if we just want to draw a simple shape like a rectangle, this isn't too bad because we can figure out the coordinate for it and all that stuff. But let's say that we want to draw a square and a circle and some lines or something like that, make something kind of fancy. It's going to be hard inside of our, let's say we want to do this a bunch of times too, in our for loop to be kind of all like relative coordinates and stuff like that. Even worse, so you can imagine doing a lot of math, like relative to x and stuff like that. Now imagine you want to draw it, that same thing like this, rotated. The math is possible, but it's super messy. You don't want to have to deal with that. So luckily, matrix transformations allow us to temporarily move the origin from over here to a new spot. So now this is 0, 0. Like that. And then we can draw all relative to 0, 0. We can do things like rotation, and it keeps track of that as well, which is really cool. So let's see kind of how that works. These in general, so things like changing the origin and rotation are something called matrix transformations. This is something from computer graphics where we're taking the matrix, the grid of pixels basically, and you're doing some kind of change to it. And there's a few commands that we're going to be using. There's today. There's push, which goes into this like temporary mode. There's pop, which resets it. We're going to talk about translate, which moves the origin, the 0, 0 point. We're going to talk about rotate, and we're not going to look at an example, but we are going to talk about scale, and there's a few others. So if you go to the P5JS reference, you'll find some examples of those. Okay, and we've been doing so many console heavy things. Now we're finally going to make a bunch of drawings. So if I run my sketch, we can see here's our screen. And remember, 0, 0 is the upper left corner, and everything's relative to that. So I'm going to, tired of that light gray. Let's make it a little darker. And just going to draw some arrows. So I'm going to set my stroke weight a little thicker. And then stroke cap is another really nice command. You can change the end of the lines. This is a lot like in Illustrator. So normally they're square. You can make them rounded, stuff like that. Cool. So there's a couple ways that we could think about drawing, so what I want to do, make this white. I want to draw an arrow like this on screen. So the old school way that we could do this would be to just use line command. So I can say, or with hard-coded numbers. So and I'm typing these from my notes because it would take me a minute to think it through. I've got a line here. That looks good. That's the vertical part. And then I could do my two sides like this. I got that. And this is where I find working on some graph paper or in your sketchbook is really helpful. You're starting to like map out coordinates. And so this is the old way. But let's say we want to draw like a whole bunch of these arrows. This is going to be super tedious. Even if it's relative to like an x and a y, it's going to be x plus 50, y minus 100. Really hard to change it. You're using it multiple times. Much easier. So we're going to call this the old way. And sometimes the old way is the right way. But we can do this with matrix I can't type transformations. We do it with matrix transformations instead. So we're going to say push, and this takes us into local mode. So this is like temporary mode where we're just like, maybe that's a better way to say it, temporary mode. And then when we're done, we're going to say pop, and that's going to reset everything back. So this on its own doesn't do that much for us, but then we can say translate. And remember, translate moves the origin. So there's my arrow. It's going to move the origin from over here, say, to right here, which should be 100, 200. So I want to move my origin now to this spot, and that new spot is now going to be 0, 0. So to do that, I say translate 100, 200. And now everything is, remember, the origin is temporarily now here, 0, 0 is here. So now I can draw stuff relative to that. So I'm going to recreate my arrow around the center. It's going to be 0, negative 50, negative 20, negative 30. So again, I'm copying this because I've spent the time to kind of figure it out. Oops, what did I do wrong? There we go. Cool. So now we see two arrows and they look exactly the same, which they should, except one of them is done with hard-coded numbers over here. That's the one in the middle. This one is done relative to 0, 0, which I think makes it a little easier to read. It makes it certainly easier to change and easier to change the position. If I want this to be 150, all I have to do is change a number up here. Pretty cool. Even better, now if I want to draw two of these, all I got to do is copy paste, and I can move this one over, and it's super easy. I don't have to change. All I'm changing is this translate function, or command. It's super, super simple. We can do one more thing. And this is really where the power of these matrix transformation comes into play. Let's say I want to rotate. I want to rotate this circle. If you wanted to do the math to figure out how to rotate this, you can, but it's a total pain. Instead, I can say, let's say I want to rotate it 45 degrees. Then I can add a rotate command here, and it's going to rotate it for me. Now, we're going to notice that it's, well, it looks pretty close, but actually if I do this, so let's say we do it 90 degrees, you'll notice that's not what we're expecting. It's some weird random thing. The reason is that angles are measured in computer graphics are measured in a unit called radians, and radians goes from 0 to 2 pi. So full rotation around the circle is pi times 2. Not a super intuitive unit of measure. Most of us are probably used to degrees, which is 0 to 360. Now, and the rotate command assumes that you're putting it in radians. That's cool, but if we want to think in degrees, if your brain works better in degrees, there's a built-in command to convert it. You just put in the command radians, and now when we run it, we get 90, 45, etc., which is pretty cool. One more really important thing to think about. Why is translate before rotate? And if you want to pause and think about it, I think it's a good kind of brain bender, but it's a really good example of why order in graphics programming in particular is really important. So if I move this here, so rotate comes before translate, it's way down here, which is not what we're expecting. Again, if you want to pause and think about it, that would be awesome. The reason is, remember, this is our origin right now. Rotate moves around the origin. So now this was our, it's pretty hard to draw a dotted line with this thing, but this was, maybe we can do, there we go. So this was our rectangle, and then it gets rotated around the origin 45 degrees. And now, make this red so we can see it. Trackpad's not cooperating. Oh my God. There we go. So now it's going to rotate like this, and it's going to draw this in place over here. Instead, what we want to do, rotate comes after translate. And now it shows up where we want it. And the reason is that we've moved our origin here, and then we've rotated. So now we can imagine our screen is much bigger, but you can imagine we're rotating around that point. So instead of rotating around here, we're rotating around the spot that we want. Sometimes you might want the whole thing to rotate, but most of the time you're going to do translate and then rotate. So those are your basic matrix transformations. One more that we didn't talk about is scale. And scale lets us change the size of something. Scale of 1 would be normal, so we wouldn't see any change. Scale of 2 would be twice as big. And you'll notice it changes stroke weight and everything. Scale of 0.5 is half size. I don't find myself using scale very often, but it can be a useful thing to put in your toolkit, depending on what you're working on. So those are matrix transformations, super powerful idea in computer graphics. It allows us to think about our code, our shape code in like little blocks that can be reused, repurposed, and placed all over the place. And in the next video, we're going to look at how we can apply the ideas of iteration and matrix transformations together to make really complex, multiple piece kind of graphics that are really, really cool. So see you there.